Okay, and welcome to this last tutorial video, and this last tutorial video we are going to cover ODE initial value problem, assignment number 11, problem number 3. Okay, turned out to be a little bit easier problem. Yeah, so stability analysis using Euler's method. Euler's explicit method. This is Euler's explicit method. Okay, so let us look at the problem. The problem is di by dt is V by L, that is 5 divided by 2 minus IR by L, R is 2.5, L is 2 multiplied by I. So, I will put the values here, the value here is 2.5. Okay. So, the lambda over here is 1.25. So, H max for stability is 2 by lambda, which so that is going to be 2 divided by 1.25, 1.6. Okay. So, if we have step size greater than 1.6, then we will have our Euler's explicit method to be divergent. That is the thing that we will expect from this assignment problem. Okay. So, case number 1 is H equal to 1. We are starting with I0 equal to 0. Okay. So, I equal to 0 initially, f is 2.5 minus 0, that is 2.5. Okay. I1 is I0 plus h multiplied by f. So, that is 0 plus 1 multiplied by 2.5. So, this value is 2.5. 2.5 multiplied by, so 2.5 minus 2.5 into 1 point equal to minus 0.625. Okay. So, 2.5 minus 0.625 into 1 is 1.875. Okay, 1.875 into plus or minus 1.25 sorry 1.875 plus 1 multiplied by minus 0.625 minus 0.625. Okay, sorry, we want to calculate f is 2.5 minus 1.25 into 1.875. Let me clear my head a bit. 2.5 minus 1.25 into 1.875, which is equal to 0.15625. So, I is nothing but 1.875 plus 1 into 0.15625. So, plus 1.875, which is equal to 2.03125. Okay. Using 2.031, we have 2.5, 2.5 minus 1.25 into 2.03125 equal to minus 0.039, and 2.03125 minus this is plus 1.9922. So, that is the value of I that you get at the end of fourth step. Okay. So, 1.9922 lies between 1.94 and 2.04. So, that is the value of y4. Now, let us do this with step size equal to 1.6. Okay. F is 2.5 minus 0, which is 2.5. I is going to be nothing but 0 plus 1.6 into 2.5, which is equal to 4. Okay. F is going to be nothing but 2.5 minus 1.25 into 4, oops sorry, which is equal to minus 2.5. Okay. So, our value is going to be I is going to be equal to 4 plus 1.6 into 2.5 plus or minus equal to 0. So, our I is going to be equal to 0, okay, and our F is going to be 2.5 minus 0, that is 2.5. Okay. Our I is going to be 0 plus 1.6 into 2.5, 1.6 into 2.5 is going to be 4, okay, and 2.5 minus 4 times 1.25 is minus 2.5, okay, and with this minus 2.5 it is going to be 4 minus 1.6 into 2.5, which is going to be 0. So, the value at the end of this iteration is going to be equal to 0. Yeah. So, with h equal to 1.6, this is exactly what you get. Okay. So, as we had predicted earlier, h max equal to 1.6. So, if our h is less than 1.6, our our Euler's method is stable. If h equal to 1.6, it oscillates between 0 and 4. So, 0, 4, 0, 4, 0, 4, 0, 4, and we will see now is if we increase h beyond 1.6, it is going to be unstable. So, h equal to 2.5 T I F T 0, 2.5, 5, 7.25, oops 7.5 and 10. Okay. Starting with I equal to 0, f is 2.5, okay. I is going to be 0 plus 2.5 into 2.5. Okay, which is 6 point, I will write this down explicitly. Okay. So, I is going to be 0 plus 2.5 into 2.5, that is 6.25. Okay. F is going to be 2.5 minus 1.25 into 6.25, which is equal to minus 5.3125. Okay, minus 5.3125 into 2.5 plus 6.25 going to equal to minus 7.031. Minus 7.031, so it is 2.5 plus 1.25 into 7.031, which is equal to 11.2888. Okay. So, minus 7.031 plus 2.5 into 11.2888 is going to equal to 21.191. F is going to be equal to 2.5 minus 1.25 into minus 23.988. And finally, we have 21.191 minus 2.5 into 23.989, which is equal to minus 38.78. Okay. Let us go at this, and you see that the solution of minus 38.8 lies between minus 38 and minus 40. Okay. So, that is the solution for h equal to 2.4, and what is the value of h beyond which Euler's explicit method becomes unstable? That value of h beyond which it becomes unstable is 1.6. Okay. So, that leads me to the end of this problem and indeed to the end of this tutorial session. Okay. Hopefully, what you have gotten from the tutorial session is some kind of an idea of how you would want to approach your examination problems. All the problems except for the first two problems, all the problems that I have solved in these 4 tutorial videos are the problems that would be probably worth 10 marks, or in the case of Newton-Raphson's method in the previous video, it would be worth 20 marks. If you recall the exam pattern that I have uploaded, there are going to be 3 10-mark questions, 1 20-mark question, and rest of the problems are going to be objective types, either MCQ, match the following, or numerical fill in the blank type questions. Okay. So, I wish you all the best in your exams, do well, and let me know if you have any questions in the forums. Thanks and see you.